Hello. Um, as he said, I'm a PhD student. You guys are a tough act to follow. In fact, Kristen, you probably don't realize it, but you're my mentor. We had contact about a year ago, and I was just getting into drones then. I had seen an APT uh, demonstration in Boston, and it was her company that did that demonstration. So they inspired me to use my drone that I had been using for photography in another way. So thank you for that. um, you obviously have come a lot farther than I have, but I did do this project with a class. We did a documentation project of a church that happens to be across the street from our university, and we used an awful lot of different documentation techniques on it, so it has a very high roof, and I thought it was a good opportunity to try my drone skills, which are in the beginning, but I think I got a pretty good result. And those of you who are interested in getting into drones, I encourage it highly, and hopefully you'll see how far I've come in a little time, and you'll be encouraged. So photogrammetry, everyone here I'm sure knows the history and what photogrammetry is. I've put this in here just for a little bit of a human element because I don't think a lot of people realize that this Albert Meydenbauer was actually the developer of photogrammetry in Germany in the late 19th century. And he was a really interesting guy. He actually developed photogrammetry for buildings. We use it for a lot of different things, you know, mapping, and we use it for statues and paintings, which we saw some of yesterday. But it was actually developed for buildings, and it makes me very happy that we all are now using it for cultural heritage. Um, he developed that institute, and they had a 20,000 photo plate archive, and you can see here that when Berlin was bombed in World War II by the Allied forces, it destroyed this French cathedral. So they used Meydenbauer's plate to do the reconstruction in the 1970s. So those plates that did survive the war got put to good use. So unmanned aerial systems, um, we call them drones. It's interesting they were developed for the military, but they've come a long, long way in commercial development, and the consumer models have gotten very, very good. Um, it says here that they've logged 3 million flight hours in Afghanistan and Iraq. I didn't realize that myself as a civilian. But what I thought was really interesting is this forecast of the market. It was done by Radiant Insights. They did this forecast, I think, in 2014 or 2015. And it's staggering how popular drones are. In fact, I think it was the #1 Christmas present last year. So the consumer models, they're getting better and better. And I have a consumer model myself. I've seen the other ones, and I drool over them, frankly, but I can't afford them either. Um, so in the commercial world, drones are doing a lot of things. You can see a listing of things here. Some of the things that may not be listed here are in the energy industry. They're using them for oil and gas mapping. They're also using them for high-powered tension utility line inspections. In the shipping world, they're using them for yard management. There's actually proprietary software that they can go and manage their container systems, find them, and that sort of thing. In the warehousing industry, they're using them for inventory tracking. And in the future, they're going to be using them for commercial pipeline maintenance and also border patrol. So maybe we won't be getting a big wall. You know, maybe we'll have drones flying around. So this is the pilot study that we did. Our class did this documentation project, and we started out using traditional HABS level hand drawing, sketching, field sketching techniques. That was the focus of the class, actually. But my fellow graduate students, Sujin, you heard yesterday, we took the opportunity to use some digital technologies on this project, and he was very good at doing the laser scanning, and I decided to try out my drone skills, my newly acquired drone skills, and I also did the heritage modeling for this project. So my focus of my dissertation is the adaptation of building information modeling for heritage. However, I wanted to go out on a limb and do this special little side project for this building. And you can see the very tall roof. It didn't allow us access. And even if we could have gotten up there on a crane or a lift, those tiles are custom 1961 mid-century modern tiles, and we were very afraid that we might hurt them. And you can see that in some places, maybe not in the photograph, but in real life, you can see that they're still kind of clipped on because they don't want to replace any of them, and they don't want them to fall down, of course. So where they're loose, they just clip them up with these metal clips. So my goal was to create a point cloud and see if I could merge that point cloud with our terrestrial laser scanning that Sujin was doing. You all saw some of his work yesterday on this church. And I was concerned that the point cloud the data might not be robust enough to be able to be merged, well enough. So that was my goal, to see if it was, and I used my Phantom 4. I was inspired, like I said, by Vertical Access. They demonstrated this model in Boston, and I was very impressed with it. I didn't know about the rolling shutter when I bought it. They shortly thereafter came out with the Phantom 4 Pro, which has eliminated that rolling shutter problem. So I had to figure out a workaround, and I did by using Pix 4D Capture. I used Pix 4D Capture to take the images, and I found out that if you use the Pix 4D Capture and use the pre-programmed flights, you can choose to stop the drone to take the image. So the rolling shutter problem really comes about when the drone itself is moving during the image capture, or if the subject is moving, which we have a building, so that's not a problem. So I just made it stop at each waypoint and to take the image. It made the flight a little bit longer, but luckily the building, it wasn't so large that I ran out of battery during the flight. So it has very good specs. Someone asked me yesterday what the megapixel of the camera image was, 12.4. I said I would find out for you. It has a 2/3 of an inch CMOS sensor. I'm used to using a full frame DSLR. So this is very small for me, but the images were quite remarkable, I thought. One of the challenges that I found with it, though, is the limited pitch of the camera. And you'll see one of the results that I got has something to do with that. So, yes, the FAA rules changed. Someone else mentioned this, and you had a different date, so I could be wrong with my date, but it was last year, late in the summer, and everyone then had to get remote pilot license. So it's not a very difficult test, not very math-oriented myself, but it was easy enough for me to pass, so I encourage you to go and take it. But you only have to have it if you're going to be doing commercial drone flying. If you have to ask if you're doing commercial, you probably are. So hobbyists know if they're a hobbyist. But unfortunately for me in my situation, I'm not doing it commercially, but I am doing it for research. And there is a small little rule that says if you do it for academic research, you have to have a remote pilot license. So, so I got one. If you're doing it just for educational training, however, you don't have to have one. There's just a small distinction in the rule about that. So the apps that I use are the Before You Fly app, and I also use UAV Forecast. I find them to be very easy to use. I have AirMap, but it's a little bit more difficult, I've found, so I don't use it as much. So this is just a sampling of the flights that I made over the church. There were some constraints flying over this church. It is on a very busy highway, not highway, I'm sorry, a very busy road, traffic corridor. It's this road right here. It's right across the street from our university, and there's a lot of foot traffic, a lot of students walking around. There happens to be a bus stop right there in front of that church. So, you know, when you're trying to avoid flying over people, I had to have a spotter who came out and made sure that people weren't there. I had to wait for the buses to come and go and unload, that sort of thing. And also the weather. In Florida, we have afternoon thunderstorms, and, you know, so I had to do some planning, and the first speaker was right. It's all about planning. So these are just some of the flight paths you can see that I took. I found the flight path app to be, with data Pix4D capture, to be very, very helpful. I tried a few manual. I commend you if you can do that. I tried a few, and it's very, very difficult to work the camera and know what you're doing as far as exposure and distance, and hold it steady and press the shutter and fly. It's to me, it was very difficult, and I found that the pre-programmed flight patterns were a lifesaver for me. So, of all of the paths that I took, I chose, after I processed them in Autodesk Recap, I didn't use Pix4D. I chose Autodesk Recap because they have an agreement with our university and they give it to us, which is nice. Pix4D doesn't have that same agreement with us. So with Recap, I processed all of the flights, and I chose the one that I felt was the most had the most data to it, and it happened to be this circular flight path that I took at 5-degree intervals. And this is the final point cloud that was processed through Recap. And you can see I was only really concerned with this top portion, the roof portion, because we had the laser scanner, and since I was trying to augment our data with the laser scanner, I just was concentrating mainly on the front, on the roof. So this is the laser scanner data, and if you pay close attention to this portion right here and right here, you'll see how the drone point cloud augments the laser scanner data. And I'll just flip back and forth a couple of times because it's a little easy to miss. So you can see it cleaned up that roof eave rather well. And Sujin was nice enough to help me to analyze this data, and he informed me that the accuracy was not as good as the laser scanner, of course, but it was satisfactory. And one of the things that helped a lot in the meshing of the data points was that the drone, the Phantom 4, has a GPS, so they were all georeferenced. The point clouds came out georeferenced, so they laid right over the laser scanner point cloud. However, this was another bit of a issue that I had. You can see the point cloud section on the left, or your right, that is the drone, and the one that's got the profile, that's the laser scanner. So this is a section of the clay tiles, and you can see that the laser scanner, in shooting up, got that really nice profile for those clay tiles. However, the drone shooting down from the sky, it was very flat, and you can also see a density difference. So it didn't really affect the fact that we were able to use some of the data to fill out the laser scanner point cloud, but it is a noticeable thing when you cut a section through the 2 point clouds. So as I said, I feel like it was pretty successful. Our project was pretty successful in this very rudimentary pilot project that I did to practice my drone skills. I did learn a lot of lessons, and I would do some things differently next time, which may not be a next time, but we'll see. Because I'm really more into my research with BIM. But it was really interesting, and I would add more flights that, and combine the point clouds to make the data more robust. And of course, the professionals, they do this sort of thing. And I would also do a plan view, which I did not do. So my conclusions are that the point cloud data is robust enough for augmenting it with our laser scanner data, and I think that it also reinforces traditional methods. We've been having a lot of conversations about traditional methods versus digital methods, and I really do feel that they reinforce each other. They complement each other. And when we did this documentation project for this church, we did traditional methods and we were learning traditional methods, but we were also using digital methods. And it's really interesting how you switch back and forth so easily. It's really you think you're learning a new language, but you get to that point where you don't realize if you're using the traditional or the digital, because it's just so fluid, a movement back and forth, especially for the younger students. They grew up digital, so they are very familiar with the digital. Older students like myself, I tend to like traditional, but the digital excites me, and I do use it. I used the point clouds when I was doing the BIM model, the heritage model, and I used the original drawings as well. So you have a mixture of the traditional and the digital. Thank you.